of the analyzer. The throughput we said is 280 tests per hour. The capacity of loading of sample on board the analyzer is 144 samples. We can load up to 25 reagent kit on board the analyzer. We have 2 titanium needles, the left arm and the right arm, and they are made by titanium, the needles for pipetting. Refrigerated sample and reagent area, so we have a cooling function for sample and reagent area. And we have incubation position, 26 position for the incubation. But as you know, our Maglumi used the 6-cup cuvette. So our cuvette can run up to 6 tests, which means that the total incubation position is 26 multiplied by 6. We can load on board the analyzer up to 960 cuvette. Welcome, Rashid. Welcome. I want to ask you if all of you are working for the same company. If all the participants in this training are working for the same company or not. So are you all working for the Diacon? So this is for the first analyzer, which is Maglumi 4000. As you know, this analyzer belongs to the M series analyzers because Maglumi has 2 series analyzers. They have the M series analyzers and the X series analyzers. So for the M series analyzer, we can list the Maglumi 4000, Maglumi 800, 2000, 2000 plus, and 4000 plus. This is from the M series. And from the X series, we have the X3, X6, and X8. The new series. Now we have seen Maglumi 4000 belongs to the M series. The next one is Maglumi 2000 plus. It is FDA cleared. The throughput is 180 tests per hour. The onboard the analyzer, we can load 144 samples and 25 reagent kit. We have also 2 titanium needles, one on the left, the other on the right. We have the same thing, refrigerated sample and reagent area. So we have the throughput, the incubation position is 16, and the cuvette we can load on board the analyzer 720. Maglumi 2000 also FDA cleared. It has the same specification as Maglumi 2000 plus. The difference is the position for reagent. So firstly, we increased the number of slots for reagent loading from 15 for Maglumi to 55 to Maglumi 2000 plus. You can see. So the same throughput, 180 tests per hour, 144 samples we can load on board, but the reagent position is 15 for 2000 and 25 for 2000 plus. 2 titanium needle, only refrigerated reagent area, so we don't have refrigerated sample area on Maglumi 2000. Incubation slot 16, and the cuvette we can load 720. Okay, so you are from different distributor. Okay, welcome everybody. So you don't have analyzers. Okay. Next is the famous Maglumi 800. So the Maglumi 800 is installed in more than 154 countries all over the world, and it is very famous. So it is also small, very small analyzer, as you can see. It is a benchtop analyzer that we can install over a table. It doesn't take a lot of space, but still the throughput is high, 180 tests per hour. We can load on board the analyzer 40 samples at one time. They are 8 rack, sample rack, and 5 sample rack, and each sample rack can contain 8 samples, so the total is 40. We can load 9 reagent kit. We use in Maglumi 800 only one titanium needle that is used for both sample and reagent. Only one pipetter. Reagent sample and reagent area are refrigerated. Sample area and reagent area are refrigerated. Incubation position 13. We said we can incubate 13 multiplied by 6 slots tests, which means 78. And for the loading of cuvette, we can load up to 240 cuvette or samples. Component introduction. Let's see the main component that are included in Maglumi analyzers. So firstly, this is the picture from Maglumi 2000. So we have the pipetter arm we have 2 pipetter arm. One is the left pipetter arm and one is the right pipetter arm that are used to pipette to distribute samples and reagent on the analyzer from the reagent kit and the sample tube into the cuvette. We have the incubator for the incubation of the reagent and sample together inside the cuvette at about 37 degrees. And we have the cuvette loader and the shaker. Here is the cuvette loader. From here we load our cuvette, and this is the cuvette stacker, sorry. The cuvette stacker is used to store the cuvette on board the analyzer. So to increase the number of cuvette, the capacity of loading cuvette inside the analyzer. We have the sample area, and we have the reagent area from this side. So to here to store the samples, here to store the reagent, and we have the washing station. The washing station is used to wash the reaction inside the cuvette in order to separate the target material we want to detect from the other unbound material, remove the unbound material that can interfere in the detection. The last component is the chamber. The chamber is the measuring unit. So in the chamber we detect the light signal emitted from the reaction at the end of the testing process using what we call the PMT, the photomultiplier tube. Let's see this component one by one, more detail about the component. Start by the sample area. We take the example Maglumi 2000. And for the sample area, the loading capacity for tubes is 144 tube, which means 144 samples. We can load samples continuously. For this example of Maglumi 2000, they are 12 position for sample rack, and each sample rack can hold 12 samples. So the total is 12 multiplied by 12, 144 samples. And we can load continuously. So each time the rack is sampled, the pipetting for a sample rack is finished, we can take it out and load a new one. So we can load continuously, load and load the racks continuously. And we have a barcode reader here on the right side. We have a barcode reader to scan the barcode labels in the tubes and send the information about the sample, the ID of the sample, and so on to the user software. Next is the cuvette loader and the stacker. For the cuvette loader, also we can load continuously our cuvette. So if needed to add the cuvette, as the analyzer use the cuvette for testing, it will let the user to have free space and load the new cuvette here. And this is the stacker. It contains 7 floors to load more cuvette on the analyzer. 7 floors. We have up to 120 modules we can load. Modules, it means the cuvette of 6 cup. This kind of cuvette. Each cuvette can run up to 6 tests. So total is 720 tests. Then we have the reagent area. For the reagent area, it is used to load the reagent on board the analyzer, the reagent kit. The temperature inside the reagent area is between 5 to 15 degrees because it has the cooling function. We have 50 positions in total in Magnumi 2000. And for the scan of the information of the reagent, we don't use the standard barcode reader, the normal barcode reader. We use the RFID reader. We use the RFID reader. Before we load the reagent kit, we move the reagent kit close to the RFID reader. In the side of the reagent kit, there is a chip. The RFID reader will scan the chip and load the information about of the reagent into the user software. Then we have the pipetter arm. In Maglumi 2000 and Maglumi 4000, we have 2 pipettors. Right pipetter, here is the left pipetter, and here is the right pipetter. They are used to add samples and reagent on the from the reagent area and the sample area into the cuvette. So these pipettors are coated with Teflon. They are covered with Teflon to prevent the carryover. One of the specificity of the Teflon is that it prevents the liquid from hanging over the needle. It prevents the liquid from stacking on the surface of the needle, which means that we will have less. Now the droplet will not stuck on the surface of the needle, which means there will be now less particles that will stuck on the needle. Then after that, we move to wash the needle in the wash station. In the wash station for the needle, it will we can reach a high level of washing for the cuvette. We can reduce the carryover, reduce the particles that can stuck on the molecules that can stuck, all the proteins or the bacteria that can stuck on the needle, and one moving from the previous tube to the next tube, or from the previous kit to the next kit, the risk of contamination will be greatly reduced. So this is the advantage of this Teflon. It reduces the risk of carryover by making the solutions, reagent or sample cannot stay on the surface of the needle. Now, these pipetter needles are made by, you can see the Teflon, recovered by Teflon. They are made by titanium for the crash proof. So the titanium also has the specificity that it can recover its original situation in case the needle is bent like this. So you can make it straight. You can correct this situation and make the needle again straight line. This can be done up to 3-4 times. So in case there is a crash, there is accident, there is collision with other part on the analyzer, and the shape of the needle is changed. So it is bent, for example, like this. Then you can correct it and make it again straight line. It has the function of liquid level detection to detect the liquid level in the tube and also detect the liquid level in the reagent kit. It has the function of clot detection. So the clot detection is only for the sample arm. It is to detect whether inside the tube, inside our sample, there is clot. So it can detect, it has the clot detection sensor. Then we have the incubator. The incubator is the component that is used for the incubation. Inside the incubator, the reaction, the solution, the reaction containing the reaction between sample and reagent will happen and will incubate under around 37 degrees. So it is 36.8 to plus minus 0.5, which means it is from 36.3 to 37.3 degree. We can load inside the incubator of Maglumi 2016 slots, but you can see that each slot contain one cuvette, one reaction module. We call this cuvette also reaction module, contain 6 cup, and the total test we can incubate in Maglumi 2000, for example, is 16 multiplied by 6. Then we have the washer station. The washer station is similar between Maglumi M-series analyzer. It contains 3 pairs of washing needle. 3 pairs. You can see this is 1 pair, this is second, and this is the third. We have three pairs. The washer, each pair contain injection needle and aspiration needle. The small one is for the injection, the long one is for the aspiration. We call also injection needle and waste needle or suction needle. The second also contain injection needle and aspiration needle, and the third also contain, and the third also injection needle and aspiration needle. So the injection needle inject the wash liquid, and each injection is 400 microliter. 400 microliter for the injection needle one, 400 for the second, 400 for the third. And the long needles are for the aspiration of the waste from the cuvette. And we have in this, so the function of the washer is to wash the reaction inside the cuvette. We need to make sure, we need to inject the wash liquid and then aspirate with another needle to remove any unbound material inside. So we have the microbeads at the end of the reaction. We need to get only the microbeads, and the target material we need to detect, and the microbeads and the ABI, which is the labeling material. So if there is any other unbound material, we need to remove it and send it to the waste. And for the washer, we have the anti-overflow function. Anti-overflow function means that in case the injection needle is not so this is the waste needle, aspiration needle, and this is the injection needle. In case the aspiration needle is not aspirating the liquid from the cuvette, on the top of the waste needle, the top of the waste needle has a signal line, a signal cable. The signal cable is connected. The signal cable is connected to the 0 volt, to the ground, and the injection needle is connected to the 5 volt in the board.
Recording in progress.
The board, the injection needle is connected to with 5 volts to the board, to the interface board. So normally when the two needles is not touching each other, the difference of voltage between the 2 points should be 5 volts. But in case there is a problem of suction, there is problem of aspiration, the liquid inside will remain inside, and the two needles will touch the liquid in the same time when the washer moves down, the washer lifter moves down for aspiration. When the two needles are touching each other, are conducted together with liquid, this means we have a short circuit. The short circuit will make the difference of voltage between the two signal lines decrease from 5 volts to a little bit less than about 2 volts, which means the software will know that there is an aspiration problem, because in normal situation, the long needle will move down for aspiration, and it aspirates when moving down. So the small needle, the short needle, will never touch the liquid. So the liquid will be only touched by the long needle, the waste needle. But if the waste needle is not aspirating when moving down, at a certain level, the two needles will touch together the liquid, and there will be short circuit. So this is how the function of anti-overflow is working. Do you have any question? If you have any question, if something is not clear, you can ask and I will repeat for you. Next is the chamber. So the chamber is the measuring unit at the end of the test. So firstly, the analyzer distributes a cuvette. Firstly, the analyzer will distribute the cuvette. Then the pipeters will add the samples to the cuvette. So firstly, we have a cuvette. Then the analyzer will add sample and reagent to the cuvette. Then this solution, the reaction will happen between the reagent and sample, and there will be incubation. During the incubation inside so here we have incubation in the incubator. During the incubation, there will be formation of the sandwich complex, antigen, antibody, microbeads, and ABI. And then we send to the cuvette to the washer for washing. In the washer, we said we remove the unbound material, the excessive component that interfere we don't need to let them interfere during the reaction. We need to remove only, keep only inside the target material. So for example, if we are detecting the TSH, we will provide the cuvette, we will add our sample, the reagent for TSH, and then incubate, and then wash. For the wash, we need to remove the other molecules that are not TSH molecules, all the other molecules in our blood that are not needed to detect. So we want only to detect TSH molecule, but in the sample there is maybe hundreds or thousands of other molecules, we don't need to detect them. So we need to keep only the molecule of TSH inside our sample. After the wash, after we keep only our TSH inside the sample, we will have the microbeads. So the complex microbeads, TSH, and then ABI, which is our marker label. Then we send to the inside the cuvette. Then we send into the chamber after the wash, into the chamber for the measurement. And in the chamber, we add the starter one, the substrate starter one, and starter two to the cuvette in the chamber. Then we take the measurements using the PMT at the back of the analyzer. We have at the back of the chamber, we have the PMT. So the cuvette will be sent into the chamber. And in the chamber, we add the starters, inject starter one, which is our substrate used by SNIPE, starter one and starter two. Starter one is the NaOH. And starter two is the H2O2. So this is the starters used by the substrate used by SNIPE, H2O2. And when we add the starters, there will be light signal emitted from the cuvette, from the ABI, from the labeling material after we add starters. Starter one, starter two, there will be light signal emitted from the cuvette. And this signal will be detected by the PMT on the back of the analyzer, this light signal. As you know, the light signal that will be detected as with unit RLU. But you know that we don't, RLU is not the result we provide for samples, for immunoassay or for any samples, any assay sample. So we don't provide the RLU, we need to provide concentration. So each time we find the RLU for any tests, each time we get the RLU for any test, we use the calibration curve for the parameter. In the calibration curve, we have the RLU. In the y-axis, we have the concentration in the x-axis. And you know we are looking for concentration. So this is the calibration, for example, for TSH. When we get the RLU, we use this RLU, the relative light unit detected from the cuvette. We use it to, we use this value together with the calibration curve to get the concentration. This is the concentration for RLU. For another RLU, for another test, we will get another RLU and another concentration. And then we have our concentration for each test. The starters, the volume injected of starters 1 is 200 microliter. Starter 2 also is 200 microliter. Then we have the system, software system. For Maglumi, we have for Maglumi softwares, we have multi-language operation interface. So we can choose different languages according to different region. If the end user require a language that is not available in the user software, he can ask for it and SNIPE will provide it. Humanized software, intelligent alarm function, and also connectable to Alias. For the consumable used on Maglumi analyzers, as you know, the system is closed system, which means that we can only use reagent from and consumables from SNIPE in the Maglumi analyzers from SNIPE. The advantage is that the reagent from SNIPE, Maglumi reagent, are used on all Maglumi analyzers. So when we release new machine, new Maglumi analyzers, they still use the same reagent. So we don't need to make registration for distributors, for example, in different countries. If they are distributing, for example, Maglumi 800, after that, if they start distributing, if we release new analyzers, for example, X3, they can distribute X3 without any registration because X3 will use the same reagent used for Maglumi 800. Same thing for the end users. If they want to change for another model of analyzer, they start, for example, with Maglumi 800 because the laboratory is small. And after that, the laboratory becomes big and need to have Maglumi 4000, for example. No problem, they can switch to the Maglumi 4000. They don't need to receive a training. They don't need to learn more about how to use the reagent because they use the same reagent. Let's see the consumables one by one. Firstly, we have the reaction module, which is also called the same name for the cuvette. They are dust proof. We need to keep away from the sunshine, direct light. We store in the room temperature. The big box contains 6 small box inside, and each box contains 664 cuvette or reaction module. When we remove the cuvette, we reseal the box. The function of the cuvette or the reaction module is that they are the container where the reaction happen and the reaction, the immune reaction happen, and also the dilution. Next is the starter, which is the substrate. So for the starters, the package is one box. The box contains one pair of starters, 2 bottles, starter 1 and starter 2. And each bottle contains 230 milliliter of starter solution. Starter 1 is the NiOH. Starter 2 is the H2O2. The function of the starters is to activate the ABI at the end of the reaction. When we add it, it will make the ABI release the light signal. We have microbeads, target material, and then ABI. Make the ABI, when we add starters, the ABI will release the light signal. And for the injected starters, it is injected at the end of the test process. The last step in the test process is the injection of starters. We inject 200 microliter starter 1 and 200 microliter starter 2 for each test. The storage, we store it in the room temperature. Before open, it is 1 year, stable 1 year. And after we open the cap and load it on the analyzer, it is stable for 4 weeks. Next is the wash system or the wash liquid or the system liquid, same name. The package is one box. The box contains 1 bottle. The bottle contains 714 milliliter. This consumables is called wash concentrate, but it is used to prepare what we call the wash liquid or the system liquid. We don't use this consumable directly. The name is wash concentrate. So we use this one to prepare what we call the wash liquid. So we will pour all the 714 milliliter of wash concentrate inside a tank of 10 liter. A tank of 10 liter. $714 milliliter of wash concentrate. Then we complete and we add distilled water until we reach 10 liter. So you can see we add more than 9 liters of distilled water until we reach 10 liters. The distilled water should be, the quality should be good. The conductivity of the distilled water should be less than 1 microsiemens per centimeter. So we need to measure the conductivity each time, check the quality of the water. The conductivity should be always less than 1 microsiemens per centimeter. So after we mix together the distilled water and the wash liquid, the wash concentrate, we wait until there is no bubbles, and then we can use it. So the dilution ratio is about 1 to 14. 714 milliliter of wash concentrate plus 9 liter and 286 milliliter of distilled water. The ratio is about 1 to 40. Then we wait. Now the recommendation is not 6 hours. We just make sure we wait until there is no bubbles inside, no foam inside, or no bubbles inside, and then we can start using the solution. The storage is room temperature also. When we prepare this wash liquid, it is stable for 4 weeks on board the analyzer. The test consumes about 13 milliliter of wash liquid. The function of the wash liquid prepared here and used on the analyzer is to wash the pipetting needles to avoid the carryover. So each time the pipetter moves to the tube to aspirate samples, for example, before and distribute in the cuvette, before moving to the another tube to pipette from the other tube, the needle will be washed before in the wash station. The needle will move to the wash station to be washed before moving to the next tube. So it is washed using the distilled wash liquid, and also it is used by the washer to separate the target material we want to detect from other unbound material in the cuvette. When the cuvette moves to the washer, it will be washed. Next is the life check. The life check is one box. The box contains 5 bottles of life check. These are the bottles. And each bottle contains 2 milliliters of life check solution. The life check inside the bottle, the life check solution is exactly the ABI. The same ABI we have in the reagent kit. So the life check is the same ABI we have in the reagent kit, the labeling material. So it contains the ABI solution, 2 milliliter in each bottle. The consumption is 20 microliter per test, but you know what? When we run the life check, we run 6 tests because we have 6 cups. So in each cup, we will inject 20 microliter. So the total is 6 tests. So it is 120 microliter, 1.12 milliliter. The storage is in the refrigerator between 2 and 8 degrees. You can see for the consumables, it is the only consumable that we load between 2 and 8. All the other consumables on Maglumi, all the other consumables of Maglumi are stored in the room temperature. So you need to teach the user, the end user, that the ABI should be stored in the refrigerator between 2 and 8. All the others are in the room temperature. And to load it, we load it in the, for Maglumi 2000 in the, and 4000, we load it in the 11 or 12 sample rack. So we have in the sample area 12 position for the rack. So we load it in the 11th, in the last 2 slots of the sample rack in the rack 11 or in the rack 12. So we put it in the sample rack. The sample rack has 12 slots, so we can put it in any slot in the sample rack, in the 12 position in the rack. Then load the rack in the position 11 or in the position 12. It is used to check the pipetter and chamber performance, the performance of the pipetter and the chamber. Next is the tubing cleaning solution. The package is one box. The box contains one bottle. The bottle contains 500 milliliter of tubing cleaning solution. And this one is only used for the maintenance during the monthly maintenance. And during the monthly maintenance, we use an empty reagent kit, a special kit that comes with the tubing cleaning solution, or you can use any reagent kit that is used, and you can clean it and use it as a tool in order to load the tubing cleaning maintenance each month. So you take the kit containing 7 vials. We have 7 vials. This is the vial 1, 7, 6, 5, 2, 3, and 4. And you input 13 milliliter in the vial number 7, 13 milliliter in the vial number 6, and 13 milliliter in the vial number 5. Then you load this one in the reagent area. First position on the reagent area. It will clean the tubing system on the analyzer, especially the waste tubing. So it will clean the waste tubing and clean the waste pump, and it will decrease the frequency of replacement of the waste pump. So the storage is in the room temperature. Before you open this box, this bottle, it is stable for 2 years. The shelf life is 2 years. After you open it to start running the maintenance using this bottle, it is stable 1 year. So the volume inside is half a liter, 500 milliliter. During the monthly maintenance, when we use it for the monthly maintenance, it consumes 10 reaction module, 10 cuvettes. It takes about 39 minutes time to finish the maintenance. It is loaded in the first position of the reagent area. And it is using 13 milliliter in the vial number 5, 6, and 7. 13 milliliter. The last consumable is the waste bag. It is disposable and it is stored, of course, in the room temperature. It is made by plastic. It is used to collect the cuvette discarded after each test finished. The cuvette will be discarded here, and this is to protect the users and the environment. So it is important to know here that all the consumables are stored in the room temperature, except the ABI, except the light check, which is to be stored in the refrigerator between 2 and 8. So that's all for this first presentation. Do you have any questions? Feel free to ask any questions you want. So let's make a quick summary. So here in the first presentation, we introduced the general specification of the analyzer. We said that we have Snipe offer a choice for the end users to choose between different model of analyzer according to their needs, according to their throughput, according to the laboratory, big and or not, or small or mid-size. And we have the characteristic change between the different model, the throughput change, the capacity of loading of samples, reagent and cuvettes also change. The design also sometimes change. So we have sometimes two pipetors, and other analyzers have one pipetor. The consumables, the component, we have seen the component, and also the main component of any immunoassay analyzer. They are the consumable storage, the pipetors, the incubator, the reagent area, the sample area, and the chamber or the measuring unit. For our system, they are closed system, and we have seen all the consumables used on our analyzers. All the consumables used on our analyzers are the cuvette, the starters that are the substrate used to generate the light by reacting with the labeling material ABI. The wash liquid and the light check and the tubing cleaning solution for the monthly maintenance. And that's all. So my friends, if you don't have questions, maybe we take 10-minute break and we start the next presentation. Okay, my friends? Is it okay? Okay, see you after 10 minutes. Okay.